Good morning, guys. So we're going to graph rational functions. So let's start with f of x is equal to x squared minus 2x over 3x squared plus 12x. Okay, so the first thing we're going to do is see if there's any way we can factor this function out to find if there's anything in common or anything we can cancel out between our numerator and denominator. So what I'm going to do is I'm going to factor out x. So x minus 2, this is what our top becomes, because x times x is x squared, x times 2 is 2x. And on the bottom, we're going to factor out x. Okay, and so when we do this, we can cancel out our x. And so let's rewrite our simplified function, which is now x minus 2 over 3x plus 12. Okay, so since we cancel out our x, that means that there's going to be a hole in our graph. So when we have a common factor between our numerator and denominator, there's going to be a hole. And we're going to call this hole our excluded values. So when x cancels out, that means a common factor is 0. And so now that we have 0, we're going to need to find what the y of this coordinate pair is. So to find that, we're going to plug 0 into our function to find y. So replacing x with 0, and that gives us negative 2 over 12, which is negative 1 over 6. So that means the y coordinate of our excluded value pair is negative 1 over 6. So what I'm going to do is go to our graph and let's find 0, negative 1 over 6. So that's here, kind of. Yeah, we're going to exaggerate the hole so we can see it better. Okay, now the next thing we're going to let's find our vertical asymptote. So our vertical asymptote is going to be vertical. So in order to find that, we're going to take this bottom part of our function and we're going to solve for that. So when we do that, 3x plus 12 equals 0. So let's solve for x, because our vertical asymptote is going to be crossing our x. So okay, so our vertical asymptote is negative 4. So let's go over to our graph and draw our asymptote. Okay, so now that we have a vertical asymptote, we also need to find our horizontal asymptote. So for horizontal asymptote, when the degree of the top and the bottom are the same, so we can see here the degree is the same, right? So we're going to take the coefficient of our numerator, which is 1, and put it over the coefficient of our denominator, which is 3. So 1 and 3. So that's our horizontal asymptote. Let's add that to our graph. Okay, that's roughly what it is. So now let's keep going. The next thing that we should find is our X-Intercept. So to find our X-Intercept, we're basically going to be solving the top part of our function. So okay, so basically when you solve for the x-intercept, you are solving for the entire function. So say you are solving for this entire thing, but when you set it to 0, you're gonna get rid of the denominator, and the other side is gonna stay 0. So it's gonna look like something like this. I just skipped this step because all it's saying is that we're gonna solve for the numerator. Okay, so x equals 2. So that's our x-intercept. So the coordinate pair for that is this. So we're gonna plot that on here. Okay. And now let's find our y-intercept. So y-intercept is when x is 0, because when x is 0, okay, so when y is 0, we have our x-intercept, so it's the opposite for the y-intercept. So let's plug 0 into our function. So our function is here. Let's plug 0 into there. Okay, so what do we notice from -1/6 as a y coordinate? Well, our excluded values, -1/6. Did we plot this? We did. So this means that it's saying that this would be our y-intercept, but since there's a hole there, that would just mean that there is no y-intercept. So no y-intercept. Okay, so with this information, we can draw our graph. So this is technically just a rough sketch, but it gives us an idea of our domain and our range, which we'll find afterwards. So let's graph this. So the line that we draw can never touch either one of the asymptotes, so it can't touch it like that. It can't touch across it, and so it's gonna go down this way. It's gonna keep going down, and it's gonna get really close to the asymptote, but it's never gonna touch it. Same thing over here on this side over here. We need to cross this point because this is our x-intercept. This is our 0, so we need to cross it, but we're not gonna touch our horizontal asymptote. So it's gonna look something like that. And on this side, again, it's just a rough sketch, but it's gonna look something like that. So that's what that's gonna look like. Now you can use this graph to find the domain and range. So let's find the domain first. It's gonna go from -infinity, because you see the lowest point this graph can go through. It can go to -infinity, and we're looking at the x plane right now. So it's gonna continue this way. So it's gonna continue from -infinity, but then it's gonna stop at 4, because this is our vertical asymptote, and your solution cannot be whatever the asymptote is. So in this case, it's -4, so it can't be -4. So we're gonna have it as parentheses, union -4. So that means -4 isn't included. Okay, and then we're gonna go to 0 because we have a hole here. So our solutions are gonna continue here. It's not gonna touch that. It's gonna continue through here. Not gonna touch that, and it's gonna continue through there. So this would be 0, doesn't include 0, and then it's going to go infinity. So our domain, basically, what this represents for the x-axis is you have solutions. So basically this graph is continuous going this way and this way, except for here and here. So that's what that means. Yeah, okay, now let's find our range. So our range is referring to our y. So the lowest point it goes to is going to keep going down. So it's going to go from negative infinity, and we have a hole again. So it's going to stop at that hole, which is here. So negative 1/6. Right, union negative 1/6. And where does it go to? So it's going to here. It stops here, and it's going to continue. But it's going to stop here again before it continues from there. So where is it stopping? It's stopping at our horizontal asymptote, which is 1/3. So it's going to go to 1/3 union, and you're going to have 1/3, and then it's going to go to infinity. So you have negative infinity to here, it stops, to here, it stops, and it keeps going. So that's this problem. Let's do one more. For this next one, it's going to be f of x equals negative x minus 1 over x squared minus 3x minus 4. So again, the first thing I like to do is factor out and see if there is anything in common between our numerator and our denominator. So I can factor out the bottom. So it's gonna give us okay, so this is fairly close to this, but it's not quite there yet. So I'm gonna change the top to become this. So now we can cancel that out. And so our simplified function would be negative, because we have this negative here, negative 1 over x minus 4. Okay, so starting with excluded values, since we have, if there's nothing in common between the numerator and denominator, and there's nothing you cancel out, there is no excluded value. But in this case, there is an excluded value, and we know we canceled out x plus 1. Now, x plus 1, what would make it 0? Negative 1 would make it 0, because negative 1 plus 1 is 0. So our x would be negative 1. Now let's plug that in to find the y coordinate of our excluded value. So we're plugging it into our function. When we do that, so I'm going to write our function. Okay, so it'd be negative 1. So it'd be negative 5 equals 1/5. So this is our hole. So I'm going to draw our hole. Negative 1, 1/5. Okay. Now let's find our vertical asymptote. Okay, so on the bottom we only have x. So what would make the bottom equal 0? Positive 4 would make it equal 0, because 4 minus 4 is 0. So that means x equals 4. Now for a horizontal asymptote, we're gonna take the top. Okay. So for this problem, it's bottom heavy. So if you look at our function, this is to a degree of 2, and the top is just to a degree of 1. So when it's bottom heavy, so if it's bottom heavy like this, you can have other stuff. If it's bottom heavy, that means that your horizontal asymptote is going to be 0. Y is going to equal 0. But if you had like what we had before, I don't know, something like this. It's the same degree, so you don't need to worry about y being 0. You just solve it to find your horizontal asymptote by taking the coefficients. But in this case, where y is just going to equal 0 because it's bottom heavy. So y equals 0, and let's draw that. So x equals 4. And y equals 0. Okay, now let's find our x-intercept. So like I said before, it's basically like solving for the top. Because when you set it to 0, you want to get rid of the bottom. So I would literally just leave you with this. And that means there's no x-intercept. Okay, so now let's solve for the y-intercept. Y-intercept is when x is 0. So our function, we're going to plug, look at our function. We're going to plug 0 into where we see x. Okay, so our y-intercept is 1 over 4. So let's put a dot roughly where 1 over 4 is. Okay, so now we have everything we need to be able to graph this graph. So it's gonna have to cross this one point. So when you shade it in, so if it's a 0 or a y-intercept or an x-intercept, you have to make sure that your graph crosses that point. So yeah, okay, something like that. And the thing is, this line is gonna get really close to here, but it's not gonna touch it. This is gonna get really close to this, but it's not gonna touch it because it doesn't touch the asymptote. So we have this excluded point here. We can't draw down here because we need something over here. So our graph is gonna be down here. Okay, so when we write our domain, we don't need to do the thing where we stop here and we continue from here because our graph doesn't have anything to do with that. Our graph continues through here and instead of here. So we don't have to include our excluded values in our domain. So let's write our domain first. So we start over here, right? So it's gonna keep going and it's gonna come from negative infinity and it's gonna keep going until our asymptote here, which is 4, and it's gonna keep going after that. So our domain means negative infinity to 4 to infinity. Okay, now let's do range, which is our y values. So we see it's going down, so it's gonna start from negative infinity. It's gonna go, and it's gonna stop at our asymptote, which is 0. I'm gonna continue from 0 and keep going from there. It's gonna go to infinity. Okay, so that's what our domain means. And yeah, that's how you graph a rational function and find its range in domain. Bye guys!